Okay, folks, let's see. We're going to have a look at question number 5 in section 7.5. We're going to be doing a normal approximation to this problem. So 5 cards are dealt from a deck of 52. The number of hearts is counted. This is a hypergeometric distribution because every time a card is dealt, it changes the probability of the next card being a heart. So it asks if it's reasonable to model this distribution with a normal distribution. And so what we need to know is that n is 5, but the total number of cards in the deck, the population number is 52. And so since 5 is less than 10% of 52, or in other words 5 is less than 5.2, therefore it's a reasonable model. So therefore a normal distribution is a reasonable model. Sorry for my handwriting. So looking at part B now, what mean should we use? Well, the formula for mean is same as with a binomial approximation. It's n times p, which in this case is 5 cards times the probability of getting a heart on any of those cards, which is a quarter, 1 out of the 4. What do we call them now? 1 out of the 4 suits are hearts, or you could say 13 out of 52. So 5 over 4 is about 1.25. It's exactly 1.25. Okay. And part C is, change colors here. There we go. Part C, what standard deviation should we use? Well, the formula for standard deviation for a hypergeometric distribution starts out as NPQ, just as it does for the binomial approximation, but then we've got this correction factor, which is NP minus little n over NP minus 1. So we're just going to plug in our values here. We get 5 times a quarter times 3 quarters times 52 minus 5 over 52 minus 1. And of course we do the square root of all of that. And that gives us 5 times 3 is 15 over 16. And 52 minus 5 is 47 over 51. And we'll the square root of that. And let's see now, 15 times 47 is 705 over 816. Square root of that is about 0.9295. Or we could say that, I guess we only really need a couple of decimal places. If we use 3 decimal places, it would be like 92.9, but then it rounds up. So it's actually 0.930. Okay. Hope that helps. Anyway, that was just a quick intro question, but I'm going to try some of the more involved ones where we actually have to use the normal approximation. Just thought we'd use this as a bit of a warm-up. Hope it helps.